Hello, fabulous Algebra 2 people, and we continue into our trigonometry, getting a little deeper. What we're going to start off with is introducing how you do the sine, cosine, tan, and their reciprocal functions on that circle that we introduced in the last lesson. So we know that in an xy coordinate system that the positive x-axis is where every initial side of an angle will sit, but as the terminal side moves around the triangle, wherever it stops, that particular point is going to have an xy coordinate, and there will be an angle associated with that coordinate. And if you want to put this in terms of a triangle, I could drop a perpendicular from that terminal side and it makes a right triangle. Now, the hypotenuse of that right triangle represents the radius of the circle, and the adjacent side is the x coordinate, and the opposite side represents the y coordinate. So when we do our trig, we can translate. We know that the sine of theta, which formerly we called opposite over hypotenuse, is now going to be the y value over the radius. And the cosine is now going to be the x value over the radius, because it used to be the adjacent over the hypotenuse. Tangent, which used to be opposite over adjacent, and still is in just a regular right triangle, but on the coordinate plane, that's now the opposite is now the y value, the adjacent is now the x. So again, and this is going to happen throughout, so y is now always going to be associated with the opposite, and x will be associated with the adjacent. R is going to be the radius, which used to be your hypotenuse, and the radius is always positive. You will never have a negative radius. Your x, y values, they will change sign depending on which quadrant you land in. So for instance, in the first quadrant, both x and y are positive. Over here, x will be negative, y will be positive. Down here, both x and y are negative. And here we have x is positive, y is negative. So now you're going to start finding you're going to have ratios that may be negative. And of course, we have our reciprocal functions, which will, remember this was hypotenuse over opposite, which is now the radius over y, and the hypotenuse over the adjacent, which is now r over x, and the adjacent over the opposite, which is the x over the y. All right, so now that we have this circle, we can do our trig in a much broader way. And again, I just also want to emphasize the relationship between x, y, and r is just your Pythagorean theorem, because it is just a right triangle. So they give us, in this first example, a point, -4, 3. So we want to draw that triangle. So that means from the origin, I'm going to go back 4, I'm going to go up 3, and then I'm going to draw my radius. And to figure out what that radius is, we do some Pythagorean theorem. So -4 squared plus 3 squared, that's 16 plus 9. So this is a 3, 4, 5 right triangle. And so then the theta we're really looking at is right here, because this was our initial side. This is sort of like our terminal side. But we use those ratios in the triangle to come up with our trig. So this is your opposite, this is your adjacent, 5 is your hypotenuse. So if I'm going to list my 6 trig functions, I'm just going to write them down first. So sine, cosine, tangent, and then remember you have your reciprocals, cosecant theta, secant theta, and cotangent theta. So to come up with the ratios, we can just look at our triangle. We have everything labeled. Sine is going to be the y value over the radius, so that's going to be 3/5, or you can do it as opposite over hypotenuse. You have two ways to look at that now. Cosine is adjacent, so notice now you're going to introduce negatives into your ratios. Tangent is opposite over adjacent, or y over x. So this is going to be 3 over a -4. Cosecant, I should have done those right away. We just go down and take the reciprocal of whatever we previously had. Secant will be -5/4. Doesn't matter where you put the negative, so long as there's only one of them. And then cotangent is going to be a -4/3. And so that's how you can come up with your 6 trig functions given any point on an xy coordinate system. You're going to want to find all 3 sides, make a triangle out of it, that by dropping a perpendicular down to the x-axis, and find your ratios. Now notice up above I drew that pink triangle and said that that's really theta. The angle that we used inside this triangle is what we call theta prime, or a reference angle. Sometimes we write it as a subscript of r, I like to do. Now, these are what I call bow tie relationships. So you don't have this on yours, but I went ahead and I quickly drew 4 bow ties on these 4 axes, xy axes. And so on this first one, we're going to talk about this concept of a reference angle. So if I have a triangle, let's say it was a 3, 4, 5 right triangle, in every quadrant I could draw something that has 3, 4, 5 triangle, and some of the sides would be positive, some of the sides might be negative. The hypotenuse will always be positive. They will all have the same trig ratio based on what the relationship is of those sides. So for instance, if I'm in the first quadrant here, this is the first quadrant, so I'm using the bow tie, the little portion of the bow tie that's in the first quadrant. Here is my theta. The reference angle is always the angle that your triangle will make with the nearest x-axis. The y-axis has nothing to do with this. We're always going to look in relationship to the nearest x-axis. Think of it as finding the nearest exit. So if I'm in the first quadrant, notice that my theta is going to equal my reference theta because these two angles are the same. But if I move, so that's quadrant 1. So in quadrant 1, whatever your angle is, your reference angle will be the same. When I move to quadrant 2, so here is the triangle in quadrant 2 that I'd be looking at. Here is my theta, because remember, it's always coming from that positive. So my reference angle, if I can write it small enough, is right there. That's like what we just did. Notice that my reference angle, I'm going to kind of abbreviate it as theta sub r, is actually going to be, because what is this angle inside? Well, the two of them together would add up to 180. So 180 minus whatever theta is gives me that reference angle, gives me the angle that's inside that little triangle. So for instance, if this were 120 degrees, my reference angle would be 60. The two of them will be supplementary. Now we move to quadrant 3. In quadrant 3, your triangle would be focusing on this one. The angle to get you there would be right here, and right inside that would be theta reference. Theta's out here. So theta's always coming from the positive x-axis. The reference angle is the angle that's coming out of the origin inside that little bow tie, that portion of the bow tie. So how would I figure out what that angle is? Well, now theta is going to actually be bigger than that angle itself. So to find the reference angle, you're going to take whatever theta is and you're going to subtract 180 degrees. To be perfectly honest, I don't use these formulas. They're nice to know, but really you're just reasoning out what is the distance to the nearest x-axis. So for instance, in quadrant 3, if I gave you 210 degree angle, well, how close am I to the nearest x-axis, where this is 180 degrees? My reference angle would be 30. It's that distance. It's that little angle in the triangle. And then lastly, we move to quadrant 4. Here's quadrant 4. So we're going to look at this triangle. Notice they always go back perpendicularly to the x-axis. The angle, the reference angle, always comes out of the origin. So theta itself is this angle. It's coming all the way around. It went past 270. Let's say it was 300 degrees. So that's going to be your theta. The reference angle is going to be, again, what is the measure of that angle? Well, if I was at 300, the distance to the nearest x-axis is going to be 60 degrees. So this is going to be 360 minus whatever your theta was. So 360 minus 300, 60 degrees. So that's how we use reference angles. They're really important when you're trying to come up with your trig value. So this is a super duper duper important concept here. So let's do a couple examples, see how this works. And we want to be able to do it in both degrees and radians. And actually, I'm going to show you a trick, because radians is actually easier, even though I know it's a new concept for you. So 145 degrees. I always like to have a little bit of a sketch. Remember, this is 180, and this is 90. So 145 is somewhere over here if I were to draw that 145 degrees. Notice it put me in the second quadrant. So my reference angle is that dot right there. What is that angle measure? So what we would do is go 180 minus 145, and that's going to give me 35 degrees, which will be my reference angle. It's as easy as that, because I would drop an altitude and it makes a nice right triangle. So if this is 145 degrees out here, this little dot inside is 35. What if I have radians? Now, I want you to notice, I'm going to write this a little larger so I can circle something. 7 pi over 6. Remember, pi equals 180. They're the same thing. One is in degrees, one is in radians. So when I see pi over 6, that's 180 divided by 6, which is 30 degrees. That is going to be your reference angle. So let's draw it just to kind of emphasize what we're doing here. So here's this 30 times, because pi over 6 is 30, 30 times 7 is 210. So the angle we're looking at comes down here. That is 7 pi over 6. If I were to drop an altitude, so here's the bow tie that I'm looking at, we're trying to figure out this reference angle. It's going to always just be this little part of it. Your reference angle, you don't really have to calculate anything, will always be just pick off the pi over 6 because, oh, something I forgot to say. Yeah, notice in all these triangles, your reference angle will always, 100% of the time, be a positive angle, and it will always be less than 90 degrees. It will always be acute because you already have a 90-degree angle when you drop your altitude, so it's always going to be something less than 90. And so if it comes to you in radians, you can just pick off the pi over 3, pi over 4, the part of it that is less than 90 degrees. Here, we can still do a reference angle if it's negative 410. It's like, what does that give me? So let's draw that. So negative 410 means I'm going in the opposite direction. Here I have gone 360. So in order to keep going to 410, I have to go another 50 degrees. So that would represent, whoops, sorry, lost my pen. This represents negative 410 degrees. And here is the reference angle, because again, wherever your terminal side is, you drop a perpendicular to the nearest x-axis. And we know that we had to go 360 plus another 50, so that means that my theta reference is going to be 50 degrees. It's always going to be that little positive acute angle inside the bow tie, one portion of your bow tie. All right, let's keep doing some more examples. Negative 4 pi over 3. Again, remember pi equals 180. Pi divided by 3, 180 divided by 3 is 60 degrees. So my theta reference here is going to be just pi over 3. It's always positive because it's always just going to be whatever that angle that was created coming out of the origin to the nearest x-axis. If you want to see a diagram of that, negative 4 pi over 3. So pi over 3, remember 180 over 3 is 60. 60 times 4 is 240. So that means that I went back 240 degrees. I should maybe do that in a different color. So I'm going to go back from my positive x-axis. I've gone 180, and we're trying to go back 240 degrees. So I keep going, and that would put me somewhere up here, because remember, this would be going back a negative 270. So we always drop that perpendicular. Here's the reference angle. So this represents negative 4 pi over 3. And so this little reference angle is your 60-degree reference angle. It's the angle that terminal side makes with the nearest x-axis. It's always going to be one of your little bow ties. And then our last one is 230 degrees. So I'll do that on the circle that we gave you. So 230, I would come around. I've gone 180. Remember, this is going to be 270, so we're not going to go quite there. So this is where my terminal side would be. So that represents 230 degrees. We drop a perpendicular, so it always makes a nice right triangle. The reference angle's always coming out of the origin. So what would that be? Well, we went 180 plus another distance. What is that extra distance? If you wanted to, you could go, so that means in the third quadrant, it's going to be whatever theta was minus 180. Well, 230 minus 180, again, is 50 degrees. So theta reference here is also 50 degrees. All right, so I hope that concept of reference angle makes sense, because now we're not just dealing with one triangle. You actually are dealing with potentially 4 different triangles, depending on, you want to choose which one is your focus depending on which quadrant you land in. Okay, so we keep going, but now we've taken our triangle, we've gotten rid of the sides of the triangle, we've put it into an XY coordinate system with a radius of our circle. Now the change we're going to make is we're going to make that radius only be 1, because we're going to look at it in terms of the unit circle, which is really going to simplify things. So now as I go around my circle, and there's your theta, if it ends here in the third quadrant, remember that means your reference angle is coming out of the origin. I can still look at this as like a triangle. But what's nice about this is your radius is always going to be 1. And that will simplify things, because all we have to worry about now is x and y, because the radius, the hypotenuse, will always be 1. So before we had cosine theta was the adjacent over the hypotenuse, which in terms of your coordinate system was x over r, but now r is going to be 1. So whenever you have a coordinate, you can just, the x coordinate is going to be whatever the cosine of theta is, because that's going to be the adjacent over 1. Sine, which used to be opposite over hypotenuse, is going to be y over r. So y was the opposite, r was your hypotenuse, but now the hypotenuse is 1. So the y value of every coordinate will just be represented by sine theta. It makes it really nice. If I just give you a xy coordinate, you know what the sine and the cosine of that angle is, because it's either going to be the x value or the y value. And just to kind of carry through what we had before, so let me write this out. We now know that sine theta is just going to be the y value. Cosine theta is just going to be the x value. Tangent, which used to be the opposite over the adjacent, is now going to be y over x. And your reciprocal functions, so cosecant theta is going to be 1 over y, and secant will be 1 over x, and cotangent theta is going to be x over y when we give you a coordinate. Now we talked about the reference angles on that last page, and the reference angles, remember, depend on which quadrant you end in, and so that you're going to start getting ratios that are positive or negative depending on which quadrant you end in, because now they're going to be based on just the x and the y value. So how do you find a trig value? You find the reference angle, evaluate the trig for that reference angle, because that will be one of your special angles. That'll be like your 30, 60, or 45, 45 triangles. And then once you know what the trig was for that angle, then you assign it the positive, negative value. So since we are going to be doing this, I always recommend you keep a running memory of what your different special triangles are. So here's a 30 degree, 60 degree. Opposite that is 1. This is rad 3. This is 2. And if I had a 45, 45, isosceles right triangle, this would be 1, this would be 1, this would be rad 2. All right, so how does this work? We want to find the tangent, we're starting off kind of difficult actually, tangent of negative 240. All right, well let's first find, as it says, the reference angle. So negative 240, I come around, I've gone 180, and I'm going to go how much further? So this represents where negative 240, where the terminal side would end. Right in here is your reference angle. It's always coming out of the origin, always to the nearest x-axis. Well, we know that 240 minus 180 is 60 degrees. So this is a 60 degree reference angle. So that's the first thing you want to figure out. Okay, so if I have 60-degree reference angle, that means that I'm going to look at this special triangle down below. So my opposite over my adjacent for a 60 degree would be tangent of 60 would be rad 3 over 1. However, realize this represents y over x, and in that second quadrant, one of those values is negative. So the tangent of negative 240 degrees is a negative rad 3 over 1. We don't really need the 1. So you found the reference angle. It'll always be one of your special triangles, 30, 60, 45, 45, because if you're doing it without a calculator. And so then you would find the reference angle, do the trig associated with that value, in this case 60 degrees, and then when you look at which quadrant it ends in, determine whether your angle is positive or negative. So I can give you a little shortcut for doing this too. If we look back up here at the coordinate system here where it shows the positive and negative, see where it says ASTC. So there's a shortcut here. All for A, that means all the trig are positive in the first quadrant. The second quadrant, S, all students, that means that sine and its reciprocal, because reciprocating doesn't change the value, so sine and its reciprocal are the only ones positive in the second quadrant. And then we keep going around that circle where everything is negative, and so we have a T here, so all students take. Tangent is positive in the third quadrant because it's y over x, which means negative over a negative. So tangent and cotangent, it's reciprocal. And in this last quadrant, we see cosine. So we have here calculus. There's a little acronym. All students take calculus. In the fourth quadrant, the only positive trig is cosine and its reciprocal because cosine goes with the x value. So anything on the right side is going to be positive for cosine, and anything above the x-axis is positive for sine in the first and second quadrant. It'll take a while to get used to this, but you will. This is still, you're just learning this, okay? All right, so we have here in example B, cosecant 5 pi over 6. So we know that our reference angle, remember you just pick off the acute part of that, pi over 6. Remember that's 180 divided by 6. So that equals 180 divided by 6 is 30 degrees. So basically we are finding the relationship of a 30-degree angle. Cosecant, remember, is hypotenuse over opposite, the reciprocal of sine. So when I look at my triangle down here, I'm going to get rid of my, why is it not erasing? Well, I want to erase. Go away, go away. Okay, so now that we're looking at our 30-degree angle, this will be the opposite. There's your hypotenuse and there's your adjacent. Cosecant of 5 pi over 6 is the same as the cosecant of pi over 6, so the hypotenuse over the opposite, that's going to be a 2. However, pi over 6, so it's 30. 30 times 5 is 300. Sorry, 30 times 5 is 150. That would put me in the second quadrant. And in the second quadrant, sine and its reciprocal are positive. So that value is going to stay positive. All right, let's move on to sine of 2 pi over 3. So that gives me a reference angle of pi over 3, which is 180 divided by 3. That equals 60 degrees. So looking at our triangle that we were dealing with before, let's see if I can We now are looking at our 60-degree angle. So this now is my opposite, my hypotenuse, my adjacent. So the sine of a 60-degree angle is the opposite over the hypotenuse. So rad 3 over 2. But 2 pi over 3, that's 60 times 2, 120. That puts us in the second quadrant. And sine is positive in the second quadrant, so we keep it as a positive ratio. And then lastly, we have here cosine 315. So what I would do, 315 is here. That has a reference angle of 45 degrees, or pi over 4, either way, but this was in degrees, so we'll keep it in degrees. So my reference angle, so if we're looking at our isosceles triangle, I can call this the opposite, the adjacent, the hypotenuse. So theta reference is 45. That means that the adjacent over the hypotenuse is 1 over rad 2, which we need to rationalize. So that becomes rad 2 over 2. Remember, the radical goes up and then the number just drops down. There was just a 1 on top before. Now, in the 315 is in the fourth quadrant. Is cosine positive or negative in the fourth quadrant? It is positive because that's all students take calculus, plus cosine goes with the x values. So in the fourth quadrant, your x values are positive, and that would be your answer. Cosine of 315 is rad 2 over 2. I wish I'd given you a few more negative ones. I'm going to throw in another example here. Let's say I wanted to know what is the sine of 210 degrees. Okay, well, 210 is in the third quadrant, and it's going to be a 30-degree reference angle because that's the difference between 210 and 180. So that means theta reference was 30 degrees. And so if I look at my 30 degree, this is now the opposite, this will be the adjacent. So the sine of 30 is opposite over hypotenuse, 1/2. But in the third quadrant, since sine, remember, goes with the y value, that's negative. Your y value is negative in that third quadrant, so now we put a negative on here. That is why we care about reference angles, because sine of 30, sine of 210, they are the same ratio. The only difference is it positive or negative depending on whether x or y is positive or negative in that quadrant. So it's all about, if you know the reference angle, you can really just use your right triangle trig to find the relationship, but it is the whole unit circle and where x and y are positive or negative that then gives that sign to the trig that you're trying to find. In the next slide, we're going to actually be filling out the whole unit circle, not just with degrees and radians, but also with the coordinates. So that is going to be an awesome reference for you. You can just look at your unit circle. So please have one of those printed out that we can then start to fill in. This is going to be one of the most important resources for you, and you can actually go online and print one out that's already filled out, but I think it's important to know how to fill it out. If we were in class, we usually have a timed trial for you to fill this out. It really only takes 1 or 2 minutes because there are shortcuts we could take, but I'm not going to, since we're not doing that, I am going to just go through the process. Here at the bottom of the screen, I want to fill out my 30, 60, 45, 45 triangles so you have those relationships, because we're going to be putting them on our unit circle. So remember that this is 1, this would be 2, this would be rad 3. For a 60 degree, everything just reverses. So that's rad 3, this is 1, this is 2, and 45, 45, we know that this will be 1 because this is also 45, this will be 1, and this will be rad 2. Now, because we are doing this on a unit circle, that means my hypotenuse is always going to be 1. So we're actually going to revise this. I want to make this a 1, I have to divide by 2. So we divide everything by 2. It's basically like a dilation. Same thing here. Everyone gets divided by 2. And then the same thing over here. Now I'm going to divide by rad 2 because I want this to equal 1. And so this gets divided by rad 2, which remember if you rationalize that turns into that, and this would be the same. So this equals rad 2 over 2. All right, so we're kind of getting prepared to fill this out. A couple other things I want to do before we get too far into it is let's fill out our signs that go with each side. So here, I'm not going to do the positive negative thing. I'm just going to re-emphasize x is positive and y is positive. Over in the second quadrant, x is negative, y is positive. So when we fill out those coordinates, every x value be negative, every y value be positive. Here, both are going to be negative. And in the fourth quadrant, x is positive, y is negative. All right, the next thing I want to fill out, and this we've already done, but I think it's worth doing again. We're going to go through, fill in all our degrees, and then we're going to go back and fill in all of our radians. So I'm going to do the degrees here in pink. So we know that this is 0. Remember that first jump is a degree of 30. And then these little jumps are 15 apart, so that'll be 45, 60, 90. Then we jump 30, so that's going to be 120, 135, 150, 180. Then jump 30, which is 210, 2, add 15, 225, and then another 15 puts me at 240, 270, 300, 315, 330, and all the way around 360. All right, now let's put in our radians. So we start at 0 radians. 30 is 180 divided by 6. So this will be pi over 3. And this will be pi over 4 because it's 180 divided by 45. So that's 45 times 4 is 180. This will be pi over 3 because it is 180 divided by 3 is 60. 180 in half is 90, so that's pi over 2. Then we get to 120. So that's like 2 times 60, so this will be 2 pi over 3. 135 is actually 3 45s, 45, 45, 45, so this will be 3 pi over 4. 150 is if I counted by pi over 6, pi over 6, pi over 6. We get out here to 5 pi over 6, and then we know 180 and pi are equivalent. So 210 is going to be 7 pi over 6. And again, this was if we went around and counted by 30. So pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, 7 pi over 6. This is how we did it initially. If I did by pi's over 4, 3 pi over 4, 4 pi over 4, this will be 5 pi over 4. This is going to be 4 pi over 3. If you think of it as 240 is 4 times 60, so that's 4 times pi over 3. And pi over 2, 270 is kind of like 90 degrees times 3. So this is 3 pi over 2. 300 is 60 times 5. So that's 5 pi over 3. 315 is going to be 7 pi over 4. 330 is going to end up being 11 pi over 6, and we end up with 12 pi over 6, which reduces to 2 pi. Now the other thing I wanted to put in here, because I want you to remember those reference angles and make those relationships. So I'm going to take all of our 30-degree reference angles, and I'm going to kind of highlight this. Because remember, your reference angles for those are right here inside. All of those are 30-degree reference angles. Then if I go to the next, the 45-degree, these all are going to have the same coordinate. They will only differ by plus or minus because they're all 45 degrees away from the x-axis. And the last one I'm going to draw, let's see, what color do you want? Will be our 60-degree reference angles. So anything along this diagonal is 60 degrees away from the x-axis. So they will all have the same coordinates, but they will differ by whether they are positive or negative. Also remember that, oops, I want to go back to my regular. Cosine goes with the x value. Sine is always going to be associated with the y value. So this is like your x and your y. Now, before we fill everything in, let's do the really easy ones. The easy are what are called the quadrantal angles, where you are actually labeling the unit circle where it hits your x or y axis. So remember, it is a unit circle, so the radius is always 1. So this first coordinate is 1, 0. At 90 degrees, that's 0, 1. At 180, it is a negative 1, 0. And at 270, that represents 0, negative 1. So again, if I wanted to know what is the sine of 90 degrees, I just look at the y-coordinate. It would be 1. And if you don't believe me, go to your calculator and hit sine 90. It's going to give you a 1. All right, now we want to put in our x and y values that go along with your cosine and sine based on your special triangle. So in the first quadrant, everything's going to be positive. The x values goes with the cosine. So when I look at 30 degrees, the adjacent to 30 degrees is rad 3 over 2. So this will be rad 3 over 2. Sine is going to be the opposite, so this will be a 1/2. Every single yellow diagonal is going to have the same ratio. So this will be rad 3 over 2, 1/2. Rad 3 over 2, 1/2. Rad 3 over 2, 1/2. The only thing that changes is now this, the x coordinate is negative. Here they're both negative. Here only the y coordinate is negative. All right, now let's do our 45, 45. Notice that the opposite and the adjacent are the same, so sine and cosine are both going to be rad 2 over 2. So anything coming off of the green is going to have exactly the same ratio. It won't change. The only thing that will change is a positive and a negative. So we can go back. Here the x value is negative. Here both x and y are negative, and here again just the y value is negative. And then our last one, I'll do that one in purple I guess, is 60. Now when you look at the triangle, well, we have a 60-degree triangle, so we can do that. The adjacent now is 1/2, and the sine is now going to be rad 3 over 2. Notice it's basically whatever you did on the 30-degree, but they switch positions. So this will now be 1/2, and rad 3 over 2. And then all of the lines coming off of the pink are going to be exactly the same. So this will be 1/2 rad 3 over 2. 1/2 rad 3 over 2. 1/2 rad 3 over 2. And then we have to go back and put in our signs. First quadrant, all positive. Second quadrant, x is negative. Third, they're both negative. Fourth quadrant, only the y value is negative. Look at that beautiful unit circle completely filled in. This is so hard because I want to show you there's a really cool trick with your hand that you can do all your trig values. So I'm going to do a little zoom, see if I can record it, because you do want to see the hand and how it works. It's kind of cool. But if I asked you, how do you use this? Well, if I asked you, what is the sine of 210 degrees? Remember, we already did this on the previous page. Now, since sine is the y value, I go to 210 degrees. I look at the y value. It's -1/2. What is the cosine of 135 degrees? Well, cosine is the x value, so I go to 135. I see it's a negative rad 2 over 2. What if I wanted the tangent of, say, 315? Well, tangent is the y value over the x value. So you make a ratio, and when you do that, you can ignore the denominators. They will cancel out, but anything that's a 45 degree, because it's an isosceles, it's always going to either be for tangent 1 or -1. So when I look at 315, I have a negative divided by a positive, same values, it's going to be a -1. And then for secant and cosecant, just find the x or the y and make a reciprocal of it. So congratulations, this is probably the most important page of the whole chapter to learn your relationships for all your trig values from the unit circle.